Pete Wright here. Thanks for taking the time to come and watch this video on a topic that sounds very abstract and esoteric. Hopefully we'll punch through that and explain it very clearly. So please stick with me for the next 25-ish minutes and we'll go through this topic and try and explain why it's an important topic. And if we've done our jobs correctly, then by the end of the presentation you'll be very clear about what an epistemology is in a computational sense, and why epistemologies aren't yet readily computable, but why it's important that in the future they do become computable. And hopefully you'll also understand that what we're presenting here isn't like a complete picture of computable epistemologies, but hopefully does move us a little bit further forward in being able to have a computer range over this type of information. So why is this topic important at all? Well, it's because what we're going to try and do is grapple what is really the most pressing problem of information management today. It's misinformation, disinformation, and what colloquially at least is called fake news. So we're going to sort of crash headlong into this topic and find out what we can do about it. But in order to explain epistemologies and for you to help you understand what they mean, we have to actually explain two earlier concepts. One of them is ontologies, and an even earlier subject to that is computable semantics. So what I'm going to do is I'm going to take a whistle-stop tour through all of these and help you understand them. I appreciate a lot of the people watching the video will already understand that. I'm not trying to patronize anybody, but let's assume that you don't, and we'll go through each of these in turn and try and learn what they are and reach forward into the epistemological processes towards the end. So semantics, computational semantics, what is that? Well, here's the dictionary definition of computational semantics, a branch of linguistics, logic, computation concerned with meaning, and the important words here are computation and meaning. So this is the area where we try and actually extract meaning out of data instead of just treating it like an abstract set of values. There's actually lots of ways of doing computational semantics. The one I'm focusing on here is one that comes from the W3 semantic web stack, which is a very big topic in its own right. I'm not really going to do a huge amount of justice here, but essentially what we do here is we present information in the form of triplets here, and we have this subject, predicate, value structure for information, and all data is held within this kind of structural triplet space with a defined set of predicates. Now, if we contrast that with other approaches for storing meaning, so typically meaning in computational sense is stored all over the place. So one example would meaning is held in the names of tables and the names of columns. It's held within the names of classes and the names of methods and properties of that class. It's held within the RESTful resource names and the JSON document keys returned in that. These are all ways of expressing the meaning of the data. But the data is held structurally within the thing. It's either held in imperative code or databases. And if you change the meaning, or if you want to add to the meaning, you need to add more structures, add more tables, add more columns, add more keys, whatever. And that's not very useful if you find yourself in a space where knowledge is unbounded. If you can sit down at the beginning of your project and produce an entity relationship diagram for all the things you're ever likely to be, and you're clear that's never going to change, then fine, please go down the traditional route of designing databases, classes, and RESTful resources that map onto that. But if you find yourself in a space where knowledge is unbounded and new things are going to happen all the time, and you don't want to keep creating new classes and new tables and new structures, then you need to move meaning out of the structural domain into the predicate domain, and that's where these triplets really find themselves of huge value. So here are three example triplets I've just plucked out of thin air. Greta Garbo was born in Stockholm, Sweden. Greta Garbo was born on the 18th of September 1905, and Stockholm, Sweden is the birthplace of Ingrid Bergman. So these are just three statements in the subject predicate value structure, and clearly a semantic statement so might contain millions, billions, or even trillions of such triplet statements. And when we go around the web and we look at data more clearly, we find actually there are huge amounts of these kinds of knowledge representational aspects which are embedded within all sorts of places. So here we have a piece of text from Wikipedia, but this piece of text is obviously designed to be read by a human with a brain. But if a computer looks at this and a computer is trying to make sense of it, then we can float a lot of information out here and hold it in this kind of triplet form. And this really shows the value of storing data in a predicate space instead of a structural space, because you can really keep adding more and more different predicates as you go on. Obviously, there's issues about predicate growth and predicate libraries, etc., and perhaps we'll have time to cover those. But as I said, the semantic web stack is a big topic in its own right, and we certainly won't cover it all here. But hold on, there's a problem here, isn't there? Because in this earlier set of very three predicates I showed, we could already see there's some stuff going on. The last predicate, birthplace of, is actually the inverse of the first predicate, born in. And we can make some other statements in. The left-hand side of the first two predicates must always be a living entity. The right-hand side of the second predicate must always be a date. The right-hand side of the first predicate and the left-hand side of the last predicate must always be a geographical location. So there's other determinations we can make about this information, which doesn't seem to be structurally held just within the triplet representation. So what's going on there? And that brings us on to the subject of ontologies. Okay, ontologies, as it says here, is a set of concepts and categories in a subject area domain that shows their properties and the relationships between them. It's very important to understand this idea of relationships between them. Ontologies help us to capture properties and relationships between data, and they tell us what happens when data interacts with other data. So they help to increase overall knowledge representation by capturing these kind of relationship values between data. Now, the best way to understand an ontology is to go ahead and look at an ontology. So this is an example ontology which is expressed in W3C semantic web ontology language format, although don't get too hung up on the exact format. But it's a good example. It helps people understand. Now, I must apologize, this isn't a very inclusive language in this example, but it does help, because it's colloquial objects that everybody understands. It does help to understand what an ontology is. So here we've defined an object property called hasWife, and we've defined an object property called hasSpouse. And what we've said is that anybody who is a hasWife is also a hasSpouse. One is a sub-object property of the other. We've said that the range and domain of hasWife is man and women. So that tells us what the left-hand and right-hand side of that predicate space might look like. And the inverse object property of hasWife is hasHusband. Now we've declared an object property called hasChild, and we've said the inverse of that is haveParent. HasChild is asymmetric, which means that if A is the child of B, B cannot be the child of A. Okay, but hasSpouse is symmetric. So if A is the spouse of B, then B must be the spouse of A. HasChild is irreflexive, which means that you can't be your own child. Okay. And you can also define property chains, like hasParent followed by hasParent is hasGrandparent, whereas hasFather followed by hasBrother is hasUncle. Now, at this point, you might be saying, well, Pete, look, all these things are fairly obvious. Why do we have to say that people can't be their own children and things like that? Well, it's obvious to us as humans walking around with, many decades of knowledge and experience in our brains. But it's not obvious to a computer. It's not obvious to a computer that simply looks at data as data and tries to make sense of it. So what we do with an ontology is we bring these rules up to the surface in a way that a computer can understand them, and then a computer can range over a series of triplets armed with a set of rules and make quite complex determinations. Now, you can actually get from a very small ontology, quite complex things can naturally emerge, almost as emergent properties from some of the rules. Often as yet unstated facts can emerge from the way these rules can interact with each other. And, there's a lot of complexities here. semantic information proceeds with a kind of an open world assumption, which is different from most places where you can't make assumptions through the absence of data, etc. So your ontologies have to be, quite wide-ranging to cover all that. But again, ontologies is also a big subject. We haven't got a huge amount of time to talk about it here, but if people are interested, I would definitely encourage them to go and look up more about it. They're actually quite fun, and the ontological statements I was making here are part of a set of ontological statements that are available here. As you can see, the crib sheet for the web ontology language runs to a couple of pages. So here you can see that you can get a feel for how much instructional capacity there is in an ontological language. So let's have a look at an example. What does all this mean in practice? Triplets and ontologies. What does that mean in practice? Well, let's look at an example. Let's say I walk up to my favorite smart device and I just say, hey, when did Bridget Fonda's grandfather die? Okay. Now, using very standard off-the-shelf sort of natural language processing techniques that have existed for a very long time, we can straight away look at the sentence like that and break it down into parts of speech, look at the words, look at the phrases, and extract subjects and objects and predicates that we think might be candidates from that. So here we said that, okay, looks like Bridget Fonda is a subject, looks like we're looking for her grandfather, and once we found that, we need to try and find out his date of death. So straight away, we can make a kind of a small knowledge graph using, at this stage, just natural language processing techniques. But using our ontology now, we can transform the graph into a format, into an arrangement which is more in line with our information. So if you remember on the previous one, we had grandfather, date after. We flipped it around to hand grandchild because our ontology has described that inverse relationship for us. So we need to find somebody who has a grandchild, which is Bridget Fonda, and a date of death. And in fact, we can break a has grandchild down into two subobject properties: has child, has child. So this is us using our ontology to do that kind of stuff. And now it's simply a matter of filling in the gaps. So Peter Fonda has a child called Bridget Fonda. Henry Fonda has a child called Peter Fonda. Henry Fonda died on this particular date. So
Bridget Fonda's grandfather died on August 12, 1982.
Not sure if that came through on the microphone so well. So here we go. The computer has answered the question, when did Bridget Fonda's grandfather die? And lo and behold, an answer comes out. And it appears quite magical at times. And the results of having a large pool of predicates and an ontology can be very, very pleasing and actually very, very powerful. And can actually make people think that the computer is doing almost human-like activities. But what it's doing really is ranging over these structures. These, by the way, aren't the only structures. There are other ways of doing it. Knowledge graphs, which is a bit like a pre-computed set of relationships like that exist as well. But there's other techniques. I'm only showing you one. But here you can see, how things work between ontologies and computational semantics. But there's a problem. There's a problem with all this. And it's a problem that was identified a very, very long time ago, 250 years ago, in fact, by this gentleman, Immanuel Kant. Because Kant realized that you can make ontological statements which are of very different types and forms, but where the ontology is not aware that there is a difference between those. So and this is his examples, not mine, by the way. He said that all bachelors are unmarried human males. And another statement is that all bachelors are unhappy. Now, any human reading these two statements will understand they are not of the same type. Okay, one is clearly some kind of definitional statement about bachelors, and one is clearly a subjective statement about bachelors. But ontologically, they are the same. Just representing them in an ontology, which I can, the computer will range over them and it won't understand that they are different. And there's a problem in this kind of structural definition that doesn't allow for that. It's a problem which he called the analytic synthetic distinction, but he was a philosopher, so he used complicated words for everything. So how do we plug this problem? What do we do to help computers understand that these kinds of ontological statements aren't the same? Well, this brings us on to epistemologies. Now, an epistemology is the theory of knowledge with regards to its methods, validity, and the distinction between beliefs and opinions. Okay, this is very, very important. So it kind of takes us to a space where instead of just talking about how data interacts with other data, we can bring in new ways of understanding knowledge. We can talk about validity, belief, opinion, consensus, veracity. All these new types of analytical models arrive in the canon. And ontologies and epistemologies fit together. Ontologies tell us what we know, and epistemology tells us how we know it. Okay, and these two things come together into metaphysics, which is a branch of philosophy that deals with first principles of knowledge and meaning. And they're not the only two that come into this. There's other branches of metaphysics. Another interesting one is axiology, which is about the value of information, the aesthetics of information, for instance, and there's other ones too. So these come under this broad topic. But ontologies and semantics are very well understood, and epistemologies aren't really computationally. And that brings us to what is actually the start of the presentation on epistemology. So everything I've covered up to now is really the precursor, the semantics and the ontologies. And what we're going to look at now is more closely is the topic of epistemologies. As you saw, we captured those other items in nice computable formats, and computers were able to range over that. A corresponding computational way of capturing epistemologies does not yet exist. Okay, and that's why we need to create one and move towards computers being able to make understandings about validity, opinion, veracity, trust, etc. Okay, so here are a bunch of statements about the movie Casablanca. Okay, what epistemological determinations can we make about these statements? Well, straight away, we can say that some of them are clearly observations of things that actually happened in space and time, but some of them are just subjective opinions. Okay, so the fact that there was a a movie called Casablanca is obviously a fact. The date in which it was released, there is a fact. The running time has a fact. But the fact that it's a romance and a war film is somebody's opinion. The fact that it's 5 out of 5 rating is somebody's opinion, and the fact that there's a synopsis is clearly somebody's opinion. In fact, it's more than that. It's a creative act that someone's gone through. So facts and opinions here seem to coexist in this triplet format, but we need some way of kind of making a determination between those. So a proposed way of doing that is to separate all predicate spaces into 2 disjoint sets, positive predicates and normative predicates. A positive predicate is a predicate for which there is a true value, okay? Whereas a normative predicate is a predicate for which there is no true value. Don't mix this up with knowing the correct value, okay? You might not know the correct value, but that doesn't mean it's not a positive predicate, okay? There is a true value is not the same as saying this is the true value, which is not the same as saying, I believe this to be the true value. Now, these 3 sentences might appear lexically very close to each other, but epistemologically, they're very, very distant from each other. Okay, so a positive predicate is any predicate where there is a true value, whether you know the correct value or not. There is obviously a whole bunch of positive predicates for which the true value can never, ever be known. What did Julius Caesar have for breakfast on the day he died? There is a true value for that. Nobody will ever know it. All possible ways of understanding the correct value have gone. But that doesn't stop that statement being a positive predicate statement. Okay. Was Julius Caesar a nice man? That's a normative predicate. There is no true value for that. There's always going to be a subjective judgment. So this brings us to our first of 4 classification schemes towards a computable epistemology. This idea of dividing predicate spaces into positive and normative disjoint sets. And they are truly disjoint in that the union between them is the entire set of predicates. Every predicate is either positive or normative, and predicates cannot be both positive and normative. Okay, they together form the union of all predicates, and there is no intersection between them. Okay, ontologically, One of the things we could say is that normative statements are dominant. Okay, so don't get too worried about the formal sort of set representation. If it doesn't make sense, don't worry about that at all. But what we're saying is that where you have an ontological statement, which is a function over a set of statements, that function results in a positive predicate only if all of the statements that went into it were also positive statements. Okay, if you introduce one normative statement into a chain, then the entire chain of reasoning becomes normative. Okay, normative statements dirty a chain of reasoning they're in. Pardon me. And we can see this when we look at, well, pardon me. When did Bridget Fonda's granddaughter die? Now this is a positive statement. Okay, there is a true value for the statement. There's actually two true values for the statement if you were concentrating earlier, because obviously Bridget Fonda has two grandfathers. So the example I showed you earlier wasn't quite correct. It should have had two values. But if we want to just have one value, perhaps I can say, when did Bridget Fonda's most famous grandfather die? That will get me down to having just one result from this thing. But hold on, by introducing the most famous, I've collapsed the entire statement into a normative state. Okay, it doesn't matter how many other predicates went into it. Just the fact that I've added most famous means that the entire ontological statement can only produce normative results now. Okay, because most famous is clearly a subjective term. Okay, her other grandfather might have been more famous to somebody else at some other time. If I wanted to get down to one result and still have a positive predicate, I would have to formulate it something like this. When did Bridget Fonda's Oscar-winning grandfather die? Now, this would result in only one result, because only one of her grandfathers won an Oscar. But it's clumsy because it requires me having previous knowledge about the Fonda family to have been able to express it in this form, which is a bit ugly, if you like. So normative predicates always creep in, really, when you're trying to do value statements. But what we need to understand is that a normative statement has an impact on the epistemology of the entire processing chain that's held within. We can also have a think about competing statements. Okay, so here we have two competing statements, S1A and S1B. It's for the same object and for the same predicate, but they have different values. Okay, and if this is a positive predicate, it's a predicate for which there is a true value, then clearly these statements are in conflict. They're expressing two different values for a positive predicate. These statements are in conflict with each other and means they should never really appear in the same chain of reasoning together because they're in conflict. They can't both be true. So if you're producing a chain of reasoning, you shouldn't pick two positive predicates with differing values for the same object, because that is a conflict. Whereas if they're normative predicates, same object, same predicate, two values, they're not in conflict. No one was saying there was a correct value. In fact, they can appear together, and in fact there's good reason sometimes for them to appear together. For instance, you might be measuring how many people thought VC over VD, or you might be comparing and contrasting the two populations of statements. So they can appear in the same chain of reasoning. Predicates like this sit quite oddly as well. Let's look at this one. Casablanca has a 5-star out of 5-star rating. Clearly that's normative. Okay, there's no true value of what the rating of Casablanca is. But hold on, it's not really enough just to say this is normative, because a rating makes no sense unless you say who the rater is. This kind of data has to be associated with somebody for it to be of any value at all. I can't just say it has a rating of 5. Well, who said it has a rating? In this particular case, IMDb might say. And something about you knowing who the rater was affects how you interact with the statement. Okay, and that brings us to the second of four schemes that we might want to look at for epistemological processing of data, which is attribution. Okay, attributing the statement to somebody, and there's actually lots of different types of attribution: author or observer, the owner, the agent, and many others. So you might, for instance, say that the For Wikipedia, for instance, you might say the author was the person who made the edit, but the owner is Wikipedia Commons, and the agent is the website wikipedia.org, for instance. So there's quite complex sets of attribution that can go on. But anyway, attribution of some statements really increases the value of those statements, and you can make more judgments about that. Another interesting one to look at is the synopsis. Okay, so the synopsis clearly is normative. Okay, there's no true value for the synopsis. There can be lots of different synopses, but here actually the synopsis for Casablanca is quite wonderful. It starts with this beautiful line, "You must remember this," which is a wonderful sort of self-reference to a song in the movie, but also a reference to the the perennial value of this movie over time. So it's a very clever thing to have said at the beginning of synopsis, and indeed it's a creative act. Somebody's done a very successful creative act, and clearly if you've made a creative act, then you should be attributed. You should say, who did this? Well, IMDb owned this creative act, and they clearly should be able to assert copyright over this synopsis. So some normative knowledge appears to be ownable by people. It appears that at least some normative knowledge, or perhaps all, can be actually owned in a legal sense. And well, we'll come on to the next one, actually, the car. So you wouldn't expect the same thing to be true of a factual statement. So there are people who starred in Casablanca, we know that, and if you look at the on-screen credits of Casablanca and you count the number of people, you find 14 people listed there. Okay, but if you go to IMDb, you'll find 112 people listed in the cast of Casablanca. So what's going on here? Well, that's because the good people at IMDb who love movies took the time and effort to research the entire cast list and crew list as well of Casablanca, and they did that in a time-intensive way. They went into the Warner Brothers archives, they trawled through all the memorandums and financial statements, and they came out with a really detailed list of the people, including here you can say man turning propeller at airport. If you remember the movie, that probably literally is a couple of frames of the guy doing that, but here he is, Raphael Trujillo. So there's work here. There's original research has gone on here by IMDb, but cast is a positive predicate. There is a true value. So can IMDb assert any kind of ownership over this? It's not clear. I mean, you can't copyright a fact that happened in space and time, but I think they can quite happily claim that they've done an extensive amount of original search to uncover that research. So it's not easy to say, when you make a contrast between positive and normative statements, it's not easy to make determinations about ownership of statements, for sure. And that brings us on to the third of four ways of thinking about statements in an ontological form, which is origination. How did this statement come to be? Was it a direct observation? Was it a reported observation, like a second hand? Was it an independent restatement? So somebody else found something that somebody else had earlier found. The independent restatement is the basis of science, for instance, recreating experiments. Was it derived or calculated or inferred from earlier knowledge? Was it original research? Is it a creative act? There's lots. These enumerations aren't supposed to be complete, by the way. There's lots of different ways we can think about origination. Okay, and this is another new way of classifying epistemologically statements. Now let's think about this one, genre. Okay, so Casablanca is a romance and it's a war film. So this is a normative statement. Somebody has to say that. There isn't a true value for the genre. But everybody agrees that Casablanca is a romance film and a war film. There's no large-scale disagreement about this. Some people might think it's a romance set during a war. Some people might say it's a war film with romantic elements. But anyway, everybody agrees with this. So some normative statements have a very high degree of consensus. So consensus means that there is a wide agreement around something which is in itself not necessarily valid to say that it's always true. And so the consensus here is very high. The consensus on the genre of other movies isn't as high. Some people might disagree whether, a movie is dystopian, for instance. They might say, well, it's not dystopian, it's just, it's just dark humor, for instance. But nevertheless, consensus is an important topic that we need to define. So let's have a look at consensus a little bit. What does consensus mean? Well, consensus is really, it's a set of all the people making a statement in an attributable fashion. And if we have a set of all those statements that people have made, and then we count the number of statements that exist of that, as long as they're independent statements, then that is kind of a function of saying how much consensus there is around a particular topic. And the consensus is clearly some way between 0 and 1. There should be no consensus around the synopsis of Casablanca. If you asked 1 million people to write a synopsis, you'd get 1 million synopsis, obviously. But one would expect a high degree of consensus around the things like the genre. You might get very close to 1, for instance, there. So consensus is a function of the number of people who are prepared to make the same declarations in this statement. But that's not the only thing. There's other things that form a consensus. You can't just say that consensus is formed of the count. We'll come on to why you can't just say that. But there's other ways of building consensus short of independently restating. If you say here, what I'm really saying is how many people can say the same thing. Okay, if lots of people say the same thing, then there's a consensus. But saying something is, quite a heavy act. So where am I supposed to go to say that I think Casablanca is a comedy musical? Okay, that's obviously a stupid statement. Well, where do I go to say that? I don't, maybe I could tweet it or something like that. Well, that brings us on to other ways of building consensus. So one lighter way of building consensus is through this device, is by liking things. Now, when somebody likes something, when they like an article or a synopsis or a tweet or anything, or an image, they are actually adding to the epistemological knowledge. They're basically giving an agreement, so they're bolstering the consensus by adding a like statement. And there's other ways of bolstering a statement. So another one here is to reference something. So if I reference that and I say, I got the information from over here, this reference is also an epistemological element which is bolstering the consensus around the statement. So there's lots of different ways of building consensus, which isn't just like restating it. Okay, there's lots of things that surround that. And that's really the fourth and final one that I'm proposing here, which is attestation. Okay, attestation is people who are prepared to attest to a statement. If it's a positive statement, they're essentially attesting to its correctness. If it's a normative statement, they're attesting to the value it brings to them in their belief systems. And there's lots of different attestations models. I've listed some here. I could republish something on my blog, for instance. I could cite something, say in my Wikipedia post, or reference it. I could like it, retweet it, tag it, comment. If it's knowledge that I've got in my processing chain, I can use it and deploy it. Lots of different ways that information can be attested. So here you can see 4 different axes, epistemological axes, around this one simple triplet statement. We'll just quickly scoot around them again. A classification scheme into a normative and positive space, which allows us to declare onto predicates whether they are normative or positive, fact or opinion. And as you can see, that line goes straight to the predicate. That's a function of the predicate, not the statement. Then we have attribution, which is a function of the statement, which is who does it belong to, who are the author, who is the agent, who is all those kind of owners of this statement live in the attribution space. The origination, which is also a function of the statement. How did this statement come to be? How did it arrive in our knowledge representation? Was it observed? Was it calculated? Was it research? And finally, attestation. How many people are building consensus around that? What different techniques are they using to build consensus around that? So these 4 things are are simply a proposal at this stage of ways of providing epistemological processable elements to what was otherwise a fairly naked statement, with perhaps an ontology, but an ontology that didn't bring into play these kinds of axes. And it's also important to understand that consensus, though, is not the same as correctness. A lot of what happens now in epistemology is that people try and establish the correctness of things. So you'll find a lot of fact-checking going on. Personally, I think this is a fool's errand. Okay, trying to decide whether something is true or not inevitably becomes highly subjective for statements where it's important to understand. Okay, for statements where it's trivial, then it's easy, but no one cares about that. Okay, so if I say human activity is causing climate change, this is a very large compound statement, and trying to establish the correctness or make statements about that inevitably means that normative statements creep into that. So it's a bit of a fool's errand, I think. Focusing around consensus is a better place to be, I think. So what you're saying with consensus is not this is correct. You're saying, look, there is a consensus around the statement using the following parameters, okay? And then you could even say there's a negative consensus using the following parameters. And you really need to float that up and let people understand what the consensus is. A good and rather trite example of how consensus on its own can't be correctness is to obviously think about these two gentlemen, Nicholas Copernicus and Pope Clement. There was a point in time when Nicholas Copernicus and perhaps a few other people were prepared to, create a statement that said that the sun was at the center of the solar system, and His Holiness here, along with the entire Catholic world and probably the rest of the Islamic world and everybody else, would say no, the Earth is at the center of the solar system. So the consensus around that statement was very, very high, and the consensus around the other statement was very, very low. It didn't really affect the correctness of the statement. The correctness of the statement is still whatever it is. Okay, so the consensus and the correctness are not the same. But clearly it does have a correlation onto trust. Okay, the more a sentence builds a consensus, the more trust there is in that sentence. Trust is nothing to do with correctness either. You have to understand, if you look at these statements, the more people trust is because they see a consensus building, they will build trust, but that's nothing again to do whether it's correct or not. Okay, and in any case, why we learn from physics, it's not everything is correct from some subjective point of view. If I'm doing agriculture on planet Earth, then it's perfectly okay for me to say that the Earth is the center and the sun is spinning around it. It kind of makes sense for me. It's what we call a domain-specific reality that works. Okay, when I'm calculating the distance to the pub, I use a flat Earth. It's fine. I don't need to worry about the curvature of the Earth. So correctness is a slippery slope at the best of times. But trust is the important thing I think we need to think about here. Let's have a little think about trust then. What does that mean? Well, a trust in a positive statement is to say that you believe it to be correct value, and that actually aligns to your truths and values. And trust in a normative statement is to say that, well, we know there's not a true value, but I kind of agree with that. That also aligns to your beliefs and values. People haven't got the time, wherewithal, or knowledge to go and independently research and verify all the information that is presented to them. Okay, if someone says to me that there is a new James Bond film and it was filmed in Spain, I haven't got the time to independently go and research whether it was filmed in Spain. I have to apply a trust vector over what I see, and that brings us into this idea that really trust is a value of the attribution and the attesters. Who said it, and how many people are agreeing with it. And as long as the people who said it are people who I can have some personal understanding of, or the people who are testing it, then trust rises. And we have this rather troublesome word, which I sometimes have called truthiness. As long as something has a kind of a truthiness feel about it and isn't completely outlandish, then really we'll reach for the attributors and the attesters to decide if we trust the statement. Okay, and here is the problem, because obviously if you're stuck in a filter bubble and you're only getting attestations from one group and you're not hearing the attestations from the other group, then clearly that affects your trust in statements. And this is where why the value of moving this into a computational space so the computer can understand that you're getting one set of attestations and not the other can help things along. And again, a fairly trite example here. That clearly, if David Attenborough makes a statement about species extinction, I'm probably just going to believe him. I have implicit trust that he probably is saying the right thing about that. But if he makes a statement about film analysis, well, I'd probably say, well, I'm not, I think David Attenborough is actually the brother of Richard Attenborough, so perhaps he has some knowledge. But still, I'm much more likely to trust Roger Ebert on film analysis. But I'm not going to trust Roger Ebert on species extinction, obviously. So who's saying it is very important. What's not really represented here is actually who's attesting it, and I think this is where a lot of the problems with misinformation and disinformation also arrive. So what about the truth then? I've actually downplayed the truth, as you'll see in this presentation. I've said that the truth is a fool's errand and people shouldn't worry about it, and I kind of draw wisdom from Oscar Wilde here. The truth is rarely pure and never simple, and that's the truth. And I think if we walk into this area of epistemology and we decide our job is to find the truth, then we've lost. We've lost from the start. It's what I call a day zero error. Okay, you wrote the first thing you wrote on the whiteboard is the one thing you can never do. Okay, don't worry about the truth of statement. Worry about the other things. Is it positive and normative to begin with? Who is saying it? What attributable values can we build around that? What is this origination? How did this information come to be? And then critically, who are the attesters? Who are the people who are building consensus around that? And if a computer can look at those things and a computer can make some information, some determination about that, then we're in a better space because the computer can say, oh, okay, on this web page or this Facebook article, the things you're reading have complicated epistemologies about them. Here are some people who agree with the statement. Here are some people who disagree. Here are some people who are prepared to test. Here are the negative views against that. And you can present a much more balanced view of doing that in a computational way without the whole route of having lots of people reading the articles and putting up, truth warnings and things like that in this kind of clumsy way, or having, machine learning algorithms which have very little semantic understanding, just processing random rule sets. This is a very, very constructive and imperative way of tackling the problem head on by bringing the epistemological knowledge directly into the computable domain. So that's it. That's the end of the presentation. Ran for a little bit longer than I was hoping. I probably waffled on a bit, but hopefully it all made sense. Towards computable epistemologies, my contact details are somewhere in the bio or somewhere on my account or somewhere, or you just go to rai.org.uk, you'll find me there. So if you're interested in this topic, if you've got some stuff to share, if you think if I've hit the nail on the head, great. If you think I'm talking complete nonsense, even better. That is also an epistemological statement that you can make. But do get in touch because really it's only through dialogue it's only through dialogue that we can come to an understanding of what we need to do here, and through consensus of all things. So that's it. Thanks very much. Bye.